Most of it is pretty straightforward, but I'm going to show you a bit of dilation factors with it, or transformations, I should say. Now, we all know that the normal distribution, the standard normal distribution, has a mean of 0 and a standard deviation of 1, because we're going from our normal probability to this normal distribution. It also has a probability density function given by this rule over here. So you're going to have to, I don't think that's on your formula, you're going to have to sort of remember that if they give you anything like this. But it can be done on calculator as well, so be aware of that, okay? Part A is not done on calculator, Part A is mostly done on theory, but the others, as we get into the actual exercise, or chapter I should say, that's when we're going to do it using a calculator. So don't be too stressed about all this done on theory part. Okay, transformations of the normal distribution. So we've got our mean and we've got our standard deviation, okay? We can graph this probability from the standard normal distribution. And this is what happens. So with these transformations, the normal x and y gets transferred to, that is, I know it's a little bit hard to see, but that is a standard deviation x plus the mean. And then the y has a dilation factor of 1 divided by, again, that is a standard deviation. I've written it in there. It says dilation factor of standard deviation from the y-axis and a dilation factor of 1 and a from the x-axis. Okay, we can see that. There's the y, there's the x. Okay, should be able to see that clearly. And also, then the x-axis has a translation of the mean units in the positive direction. And of course, the mean has to be greater than or equal to 0. Greater than 0, sorry. Okay. I'm going to clear all that because you guys should have all that written down. You can underline as I'm going. Now, of course, conversely is the same thing. The transformation which matches the graph of the normal distribution with this mean and standard deviation to the graph is given by that. So, of course, we rearrange them. Okay, we get our x values and we put it in there because this is our image, just like we do before. Okay, translation of units, mean units, I should say, negative direction of the x-axis, followed by dilation of factor 1 divided by the standard deviation from the y, and a dilation factor of standard deviation from the x. Okay, we can see that. Okay, that must have been Jaden. Welcome, Jaden. Okay, so I've marked in here. Okay. Now, clear this. Now, the general rule for the normal distribution. If it's a normally distributed random variable with the mean and standard deviation, then this is the probability density function. You can see that is the standard deviation in there, and you can see in here, in the bracket, it's x minus the mean, all divided by the standard deviation, all squared. Okay. The other thing that we can use is convert from our x to our z, is using the rule of a minus the mean divided by the standard deviation. That's our z random variable. So be aware of that. Okay. That's also important in this exercise later on. Okay, we know it involves two parameters. We've got the mean and the standard deviation. Okay. It's got a few properties. Okay, it is the area under the curve if we're looking at it, and of course it must add up to 1. It has to, because the normal density function is like a probability. Okay, adds to 1. We know that the center is normally it's the median in this case because it's evenly spaced, it's the mean, and the width is the standard deviation. So this is stuff that's normal. You should all know this already. The only things that you wouldn't know are these, well, that rule in particular, that one you might already have known in year 11 about changing it to the Z value. Can't remember if you guys did it in the year 11 or not. Okay, so a few things that happen with the graph in case they ask you for the graph. I think there's one question in the book which asks you for the graph. By the way, remind me to do that other question for you. Okay, here's the graph. F of x is shown. Okay, we have it. There's our mean. Okay, and we have the standard deviation. Okay, sorry, 1 divided by the standard deviation times square root of 2 pi. That's the maximum value of it going up. Now, we can change things. So we know that the curve, the location of the curve is determined by the mean. Of course, the higher the mean, okay, the bigger it's going to go from the zero value. The lower the mean, the closer it's going to go to the zero value. And the steepness is determined by the standard deviation. Okay, these two are equal. Standard deviations are equal. But have a look at this second one over here. The means are equal, okay, but standard deviation of the first one is less than the standard deviation of number 2. But look what happens. If it's smaller, because it's 1 divided by, it comes higher. Okay, higher up. This is the standard deviation of 1. This one here is a standard deviation of 2, which is bigger. So look, see, be careful with that one. A lot of students get that one confused. Okay. Doesn't matter what the mean standard deviation is, you're always looking for the area under the curve of a normal density function. Okay, here's a couple of examples. Example 1 says, on the same set of x's, sketch the graph of the probability density functions of the standard, normal, and the normal distribution. Okay, the first one's with a mean and standard deviation of 1. Okay, so this is our normal. Graph has been translated 1 unit positive direction of the x-axis. Okay, then this is what happens. There's our standard normal distribution with a mean of 0 and a standard deviation of 1. So all I'm doing is putting the mean of 0, got to get my annotation up, the mean of 0 into my rule. That's the normal rule that we gave to us. So the mean of 0, so that's 0 in there. Standard deviation of 1, 1 in there, 1 in there. So there's my rule. But for the other ones that normally happen, and I can't move it, which is being translated, okay, there is my mean. It's been translated 1 unit, so my mean's shifted to 1. There it is there, mean of 1. Standard deviation has remained the same height. I can see there. I can't go back up to show you, but there's a standard deviation of 1. So this rule, I've got a 1 here. I don't need to write it. And of course, I've got to divide by 1 there, which I don't need to write it. So that's what the new function comes there. Now I'm going to go up to B so you can see it. Okay, we've got a mean and standard deviation of 2 here. So this is what happens. Our xy, remember there's the rule for our translations. Rules for our translations are there. So I'm substituting the standard deviation of 2 in there. And I've got my plus 1 for the mean. And I've got my y divided by my standard deviation of 2. So we know that this graph has been dilated from the y-axis by a factor of 2, from the x-axis by a factor of a half, and then translated 1 unit in the positive direction of the x-axis. So this is what happens from the normal to the translated one. Now I'll show you the rules. Okay, so there's the normal rule. Okay, mean of, can I go like this? Yeah, mean of 1. Mean of 0, sorry, standard deviation of 1. Okay, I get the same thing as I did in the previous one. There it is there, and there it is there. That's exactly the other one. For this one here, we've got a standard deviation of 1. And, sorry, not a standard deviation of 1, it's up the top. Let's have a standard deviation of 2 and a mean of 1. Standard deviation of 2 and a mean of 1, so I'm using it in here. Standard deviation of 2. And there's my 2 in there, and mean of 1. So that becomes my new rule. Okay. All right. Let's see what else is there. Okay, that's 16A. So that's what you do on that 16A. Let me have a quick look. When they ask you to do E of X, remember, I'm going to show you this because I don't know if we've done it before, but E of X, the mean of X the mean of x, when we got a probability density function, is going to be x times our f of x. So be aware of that. So there's my f of x for this one here. Okay, if they want me to do the mean of x for here, I'm going to get that, and then I'm going to put a times by x next to it. Okay, and if it's between for an area, then I would be doing the integral between those two points. So let's say they're A and B of x times f of x, depending what that is. Okay, but I'm sure we'll be doing that in the next exercise. All right, so I wanted to do that one with you. Well, I have now. The other one, someone asked me a question yesterday. Oh, I didn't even check. Was that the last thing on that one? Better check. Yeah, okay. Someone asked me a question yesterday, question 7. I can't remember the exercise. 14, was it 14C? 14C, question 7, I'll think about it. Yes, 14C, question 7, where I said we would be doing this on the calculator. Okay, so I'm going to share my calculator. Well, that's not it. That's not sharing the calculator. Share. Calculator. All right. I better start a new document. No. Okay. It's question 7 from 14C, which was they were asking us probability that we had to do 1 minus x was 0, 1, 2, 3, all the way to 49, because it had to have greater than 50 goals and being the probability of more than 0.99. Okay, so I'm going to do that one again because I did do it, and binomial CDF. Okay, this time here, hang on a second. I'm doing define the bin n equal to 1 minus the binomial CDF. Okay, now n is what we want to find. Our probability was 70%, 0.7. I had all that right. And my endpoints is supposed to be from 0 to, was it 49? And she scores $50. 0 to 49. I don't know why I was writing 0 to 2 before. So there we go. I've done that. Now I will go to this and Control T and press my enter. And now I've just got to go all the way down to get 0.99. 0.06, 0.77, 0.98, 0.99. There we go. It's that one there. I'll make it a bit bigger. I don't know why it's not showing you the 0 point, but you can see it in the graph here. 0.99 is what we wanted, and 0.99 is at 86. So the answer to question 7 of 14C is 86. Okay. That's the question someone asked me yesterday, and I couldn't get it yesterday. I got it straight after it. All right. Any questions on that one?